Today we will discuss about product teardown and experimentation. So in product teardown is a process of taking apart a product to understand itself, understand how the company making it succeed. So purpose is dissection and analysis using reverse engineering and redesign technique. Gain the user experience and knowledge as a material of study. Competitive benchmarking. Steps: list the design issues, prepare for a product teardown. Teardown in the sense kind of breakup. So exploded view you can see in 3D modeling. So similar to exploded view in that teardown activities. Examine the distribution and installation. Disassemble, measure, analyze data by assemblies. Form a bill of material. BOM means BOM is a bill of material. List the design issues. Identify the purpose of the teardown. Determine what model should result from this process. Create a data sheet in which all the information can be captured. A preparation is gather the tools that are required for disassembly, document the process. Examine distribution and installation. How to acquire the parts, how to distribute and market the product, how is the product packaged, what is involved in installation, examination of consumer installation instruction and procedure for the cost and effectiveness and liability. Disassemble, measure and analyze. In that, take a picture, run, analyze and measure. Coordinate disassembly with measurement, experimentation and modeling. Avoid destructive disassembly. So, creating a BOM. Bill of materials, list of raw materials, sub-assemblies, intermediate assemblies, subcomponents, components, parts and quantities of each needed to manufacture 1 unit of the product. If 1 unit of the product is there, in that how many parts are going to assemble like that. So in one human body, there are 2 eyes. So in eyes section, quantities are 2, like that. So even though the assembly is 1, you can't say 1 part. It can be a many part that way. Then single level BOM. Display the direct components to make assembly or sub-assembly. Intended BOM. Display highest level item closest to the left margin and the components used. Modular BOM includes description of all associated assemblies and sub-assemblies. These are the varieties. Just have a look what the BOM and how BOM is there. Here one example of BOM. Here you see this is a serial number, that is running serial number. This is the quantity required for 1 assembly. Then there is an identification mark, maybe some sort of code numbers. And these are the description in detail about that part. Then each item having their part number. Those are unique identifications. Then there shall be a remarks like, motor starter A, that way. So here, item number 1 quantity CB104, circuit breaker, 3 pole, 30 ampere, 480 VAC. The part number is G3P-030. Like that, there is a list of items required for 1 assembly. So here, if you see the creation of an exploded view. So it is nothing but an assembly is going to have an assembly, but it is kept in a distance so that the part orientation and the assembly can be understood very well that way. That is what exploded view. Exploded view normally refers with respect to x-axis, y-axis, and z-axis. So what are the axes will be referred to the related part that we can see here. Apple iPhone 5s 16GB is the product. In that product exploded view you are seeing. Here is the display module that is in front of you all the time, a mobile having in front of that. Then beneath of that, there is a display backplate, and below of that, home button and fingerprint sensor PCB, and above of that, secondary camera module PCB, and beneath of that further, main PCB is there, loudspeaker assembly is there, IO connector and headphone jack is there, and the entire frame you see at the bottom, it is enclosure, aluminum enclosure, main bottom. So above that there is a LED flash PCB is there, antenna is there, and battery is there. So it is an exploded view, and accordingly you need to make a BOM of that. What are the things it is required? It's not related to that, but however the things are like that only. Some people also put some of the small photo reference in front of that BOM list, so that item number and description also can identify with the shape or a kind of reference figure. So that is much easier to see into it. Here functional models focus on what it does, not how it does. Demonstrate the product transformation and of materials, information, and energy. Hand energy. So hand induces transitional force. So transitional force converted to rotational force. In the same time, hand energy, if you see the plug-in cord, so the plug-in cord, then it also puts input, electrical energy to the device. Then it converts the electrical energy to the thermal energy. Here, parallelly, if you see transitional force converted to rotational force, then it come directly here, source glue stick and translate glue. But here, once it is converted electrical energy to the thermal energy, it is going to tactile feel heat, or means it is a touching heat. Then, or it is actual heat, or it is going to be guide and melt the glue, and guide and export the glue from the device, then correctly placed on the melted glue. So here the electrical energy input supply, here the glue stick, and it is an insert glue stick, like a, in a gun it is a like a candle type glue stick will be there, then guide glue stick, then secure glue stick. So it is hand energy will also push into it, then translate that glue into guide, so that guide will be get melted because of the heat. So this is how the actually the gun works, glue gun works. So here it is a aim. So aim is related to wherever the point you need to stick to the glue, that you need to point out and push. So benchmarking and establishing engineering specifications. So in that background, know your enemy to know yourself. Benchmarking approach. Support tools for benchmarking. Proposal on opportunities for redesign. Thoughts on benchmarking and competition. Setting product specification. So here, one Chinese warrior, that is Sun Tzu, Chinese warrior in 500 BC, he told, know your enemy before to know yourself. In 100 battles, you will never peril. So product development teams must understand not only their product, but more importantly, how other competitors provide the similar products. So every current tear down activity should compare the competition's new models with the past tear down activities of the previous models. Competitors' growth and direction becomes clear. So Xerox worry of 1970 about Canon copier. So benchmarking is the key. So what is benchmarking then? It is an activity in the product development process and overlap many other activities. It is an important step in establishing engineering specifications, the kickoff for responding to the completion, and it generates a wealth of data to understand a product and forecast its future development, provides a standard or point of reference and range that can be used to judge the quality, value, or performance. Perspective can be gained on what the best-in-class product is and what makes it so. Xerox definition, the continuous process of measuring products, services, and practices against the toughest competitors or those recognized as industry leaders. Objectives of benchmark. For the front end of the design process, for identifying customer needs, for improving concept generation, for embodying a product, for establishing the product specification, including the cost, for executing the detailed design. Benchmarking approach. Step 1, form a list of design issues. Step 2, form a list of competitive or related products. Step 3, conduct an information search. Step 4, tear down multiple products in a class. Step 5, benchmark by function. Step 6, established best-in-class competitors by function. Step 7, plot industries trends. So it's a kind of activity. Form a list of design issues. List out design issues primarily from the customer's input, which would form as the basis of benchmarking. It's important for this list to be continually revised and updated. Form a list of competitive products. Identify the competitors. An entire set of products in the portfolio must be listed. Only identifies the products details to follow. Conduct an information search. Be honest and ethical. Only depend on reliable sources. Gather the information regarding the competitive product before benchmarking, which would include the product features, product materials used, parent company, manufacturing locations, customers, market share, target segments, related products, functions they perform, problems faced by customer, any other information. So these are the standard criteria need to be listed down. Tear down multiple products in class. Recording of information, same as the product tear down process we learned. Output, BOM, functional model, exploded view, function to form mappings, and measured performance levels. Benchmark by function. It is tough to benchmark each component because of limitations such as availability of large varieties, geographic limitations, patented part etc. Then always better to go with functional equivalency approach, result functional model of the product. Established best-in-class competitors by function. Break up by each function and call out the best performing solution. We may also say that cheapest solution for this function also, which would be important for customer. Plot industry trends, categorization of the market, technical solution benchmarking, competitor benchmarking, performance over the time for the portfolio, supporting tools for benchmarking, intended assembly, cost analysis, function form diagram, trend analysis, and opportunities for a redesign. Intended assembly cost analysis. The cost associated with the development of the product is function of the material, equipment, and labor cost. An intended cost estimate organizes the results analysis according to the hierarchy of assemblies, sub-assemblies, parts, and features. This would be very based on demography, the skill of the labor associated with it, and the business would have to put it a margin of profit on top of it. Practice in how labor cost countries business undertake complex assembly processes which are mostly inexpensive parts. High labor cost countries design with a complex multifunction parts, so that number of manual or number of sequences need to be reduced. Use product teardown process to understand detailed overview of the parts, its associated assemblies. Intended assembly cost analysis, to understand it, use product teardown and node. Down for each part and assembly structure, that is, what is attached to what is the cost of each part, what is the cost of each assembly step. Way of reducing the part cost is to attack the costliest component and costliest assembly step. Here you can see the function form of diagram. The result of benchmarking analysis should be listed on the function form diagram, including the details of part count, cost, and any material information. So whenever you power it, input is 110 VAC or 220 VAC or 440 VAC. So accurate power in ECU and switch to 110 VAC or 220 VAC or 440 VAC. Here the concept, then top switch, pivot lead. So parts, number of parts, then cost, then the materials related to lead, the button, then pusher, then switch, then contacts in the sense power carrier contacts, then class. So each top switch, brown groups, Krishnat, then pivot lead groups. This is a comparison. So function form diagram for accurate power subfunction. In power subfunction, what is Brown using? What is groups 2 using? What is Krishnat using? And in pivot lead, what is groups using? So it is a comparison among the parts. Here see, the parts are 5 altogether. Here it is 3. Then the special class, the Krishnat quality. Trend analysis, to find where the product and industry are headed, becomes clear with benchmarking analysis. Either quantitatively S-curve or qualitatively comments by senior executives. What direction should be taken for redesign opportunity? Avoid chasing the competition. Determining the engineering characteristics. There is a need to translate the customer requirements into language that expresses the parameters of the interest in the language of engineering characteristics. This is a set of engineering characteristics that will include the parameters, design variables, and constraints the design team has to begin to collect through research, including benchmarking and reverse engineering activities. The team may have some idea of what the most important characteristics are, but this cannot be determined until the next activity is completed, and that is creating the house of quality. We'll see the house of quality. Very next slide. So this is a set of engineering characteristics, and that will include the parameter, design, and variables. It is the same thing. Then quality function deployment. Quality function deployment, QFD, is a planning and team problem solving tool that has been adopted by a wide variety of companies as a tool of choice for focusing design team attention on satisfying customer needs throughout the product development process. The term QFD refers to a fact that this method determines the important set of requirements for each phase of PDP planning and uses them identify a set of technical characteristics of each phase that most contribute to the satisfying requirement. So QFD process is quality function deployment, in that process of converting and documenting the customer's requirement into technical specifications. Normally done by a team of people who may or may not be collaborate with from other departments, primarily communication activities. Two types of team: new product development team and enhancement of existing product. So both team are pertaining to that QFD process. Examples of team include marketing, design, finance, etc. So in the finance, in the sense, the costing department, those who are directly responsible for generating the quotations, proposals, those are related to that. So identify the customer, determine requirements, constraints, prioritize requirements, competitive benchmarking, translate requirements to measurable engineering specifications, set target values for each specifications. What are the benefits of QFD? The benefits are customer-oriented product, focus on customer requirement, reduced implementation time, promoters teamwork, facilitation documents, customer-driven. Focus on requirements specified by the customer, facilitates effective use of competitive information. Resource prioritization, prioritize the actions and provide well-built and can be acted upon experience or information. Reduce implementation time, decreases midstream design change, limits post-production problems, avoid future redundancies. So identifies future application opportunities and surfaces missing assumptions. Promotes teamwork because it requires different departments. And consensus of team members is the priority. Facilitates effective communication at interfaces. Identifies the actions at interfaces. Creates global view out of available details. Provides documentation. Documents rationale for design. Easy to estimate. Provides structured information. Increases adaptability to change. Gives a framework of sensitivity and assembly. So how does the customer get advantages from QFD? Built upon the voice of the customer, because it is a thought process from customer itself. Focus on customer satisfaction. It is pertaining to only the satisfaction of customer, not related to anything else. Ensure the effective information gathering. Turns information design specs, prioritizes design features, produces the house of quality. So here you can see how the project resources versus time being allotted. So does your company needs EQFD? So that is project beginning from here, the time and launch deadline, that is product launch deadline. Here the approximate timeline and approximate activity you can see, averaged activity you can see. In that normally everything piles up at the in and around of the launch deadline. So what are those things? Firefighting, panic and redesign, problem solving, because anything goes wrong during the final assembly, then only we will let you know. There is no preparation, pre-planning, plan B. So that way, problem solving it also requires. Costly, mid-course corrections, last-minute changes, poor communication, walk-a-mole engineering, and blame. So, lot of activity concentrated on launch deadline, which may adversely affect either the product or the brand name, and it is definitely dent the cost itself. At the same time, if you proactively develop that activity much before to the deadline, then that whatever the launch date deadline is there, that become a very soft. So here, those are the activities. Better planning, intense customer focus, voice of customer, not the VOE. So here, improved documentation, improved communications, cross-functional teamwork, doing it right the first time. This is very important, right at first time. If you do anything right at first time, it saves a lot of money. It represents you as zero defect man. So right at first time, anything it is getting right at second time or third time or fourth time or n number of time, then the n cost will be multiplied to it. Then overall cost and time is magnifying with n that way. So you can pay me now or you can pay me later. That's what the activity says. So what does the area under the curve represents? So here reactive development process and green is proactive development process. So top reasons reported for product or project delays and failures. We'll discuss this even in project management also. These are very key issues which everyone forgets, that's why. So poor product definition, that is number one reason. These are the scaling you can refer. So what are the mistakes, top reasons to fail, either the product or project, whether it is a fail or delay or something else, postponed kind of thing. So number one is poor product definition. What you defined is not what you produced, that way. And technical uncertainty and difficulty. Maybe you thought of making, moon in your house, but you could not be able to do so. So whatever you are thinking, that may be your wishful act, but it is not feasible. That way, there is an uncertainty, or maybe it is too much difficult to manufacture or produce. Then lack of senior management support. Maybe you are thinking very much, ground level, what are the practical aspects, impacts. So you are studying everything, but you could not be able to communicate with the top management and they could not be able to coordinate with you on time. Maybe a lack of support kind of thing. Or so this gap creates a havoc in delays and failures. Then lack of resources. Maybe you would not be able to plan well in advance. Because of that, there is a shortages of resources. Or maybe you don't know the awareness of those resources on time. So that would again, having a more expense on to the requirement. Then poor project management and failure to the strategically prioritize efforts and poor communication. So all these are major reasons, top reasons reported for these activities. So which one do you think EQFD will help? So here, some of the things, so EQFD will help you. Poor product definition, of course, much high. Poor communication, failure to strategically prioritized efforts. So rest of the thing equally it is going to help. Here, basic product development steps. Identify a project and organize a team. Voice of customer requirements. Determine, document customer requirements. Prioritize requirement, development performance metrics and targets. Evaluate competition and prioritize opportunities. Then product design. Generate design. See, however, this identify a project, this total project management will study in another chapter as well. So we'll go to the product design aspect. Generate design ideas and concept. Select best design ideas or concept. Assess the product risk assessment. The same business assessment is also there. Detailed product design optimization. In that, the process design. Generate process ideas, concepts, means sequence of operations to manufacture those products. Select best processes, ideas, concepts. Access the process risk, access controls. Detailed process design optimization. And launch or continual improvement. Basic activities, simple flowchart of the EQFD process. So, project plan, project character, charter, design and conduct qualitative and quantitative customer research, document and prioritize VOC results, refine VOC benchmark competition, develop metrics and target opportunities. Concept generation and evaluation. Detailed project design by using CAD, of course. Optional, detailed manufacturing process design and production control. In earlier days, it was very much mandatory. Nowadays, it become a different department of that. But it is the part. If you don't know how to manufacture and how to control, then maybe that will lose the sheen of that accuracy of that product. So that's what it is combining with. Here, product development, EQFD global map, roadmap. I will put here. Project charter started here. Consist, so gathering the voice of customer, it's activity. So qualitative, VOC and HOC, vast process, affinity, quantitative VOC. Then here, pre-HOQ, priority map. Innovation toolbox, 25 plus concept generation evaluation, selection tools with a QFD. And customer root wants, house of quality, EQFD formed here. Measures, CTQs, critical to the quality. And Lois objectives, customer perception, targets. Then it resembles the innovation toolbox and function mapping, design deployment, EQFD2, then EQFD3 process planning, EQFD4 that is production control. So then we'll understand the house of quality. So answer the questions accordingly. You will identify this. Who are the customers? Who are your customers? Then what are their needs? How well are the customers satisfied now? How will you determine if their needs are met? How much is good enough performance? And analyze your answers at each step and capture your results in the house of quality. This is house of quality. Here, relationship between customer needs and product design requirements, what's and hows will come here. Prioritized customer needs and customer needs, what's will come here. Prioritized product design requirements come here. Product design requirements, hows will come here. Hows and hows versus hows. So relationship among the product design requirements and product design requirements will come here. So house of quality or quality function deployment of house of quality. Number one, who? Number two, what? Number three, who versus what? Here, compile the data from who and what. That is comes under three. Who versus what? Now, the 5 is how and 6 is what versus how. 2 and 5 versus become 6. Then how much? 4A now, 4B is now versus what? Now versus to what? So here the what is needs on research, who is customer research, and how is technical research, and the now is product research benchmarking, and how much it is engineering specification targets. It is a reach. Then QFD metrics. So interrelationship between the technical descriptions, correlation matrix, how versus how. So if you go by marking, then +9 is a strong positive, +3 is a positive, -3 is a negative, -9 is a strong negative. Here, the technical descriptions will come here. We'll go one of the example as well. Just understand what is this house of quality QFD matrix. Then the primary, secondary aspect will come here. Customer requirements will come here one by one. Technical completion, competitive assessments will come here. So similarly, degree of technical difficulty, target values, absolute weight and percentage, relative weight and percentage. And the target values are here, prioritized technical description. L-shaped diagram means here horizontal requirement to vertical requirement. Relationship matrix. So you have to correlate with the facts, technical descriptions and customer requirements you need to correlate. Correlation matrix. Customer requirements versus technical descriptors correlation. Here is the legends. Weak, triangle is weak, round is medium, point is strong. Customer competitive assessments. So customer requirements list, you have to assess those things. So customer competitive assessments of hours, A's and B's. So QFD sequence is product characteristics, component specification, product process, and quality plan. So how the things are flowing? House of quality translate customer requirement into quantifiable design valuables, then called engineering characteristics. So here engineering characteristics versus customer requirement, that is having a product planning. Then it will go here. So the part characteristics and engineering characteristics, part deployment. Then it will go here, part characteristics, manufacturing process requirement, EQ3 here, process planning. Then EQ4, that is production requirement versus manufacturing process requirements, production planning happens here. House of quality, most complete configuration. Room 1, customer requirements, CRs, watts. So, importance rating. Room 2, engineering characteristics, ECs, how. Room 3, correlation matrix, improvement directions and units for ECs. Room 4, CR to EC, relationship strength codes for room 4. Room 5, importance thinking. Room 6, customer assessment of competing products. And room 7, technical assessment. And room 8, target values. So, room 1, customer requirements, watts. So, the importance rating of CRs are 1 through 5, where 1 is least important and 5 is most important. Similar way in room 2, engineering characteristics, house. And relationship matrix, CR to ECs. And absolute importance, room 5. Parts 5A, 5B, 5C. Importance ranking of ECs. Here you see, there is a list of customer requirements. What are those things? It should be weatherproof, accurate ball return, all weather condition. Toolless installation, no tools required. 5-year lifetime warranty, means at least 5 years. Quick return, store in garage, means not store in sophisticated area, it is store in garage, means it should be robust and withstand. Compatible with all hoop installations, does not jam with a rust or sort of thing. Catch most shots. Then non-abrasive, it should not be non-abrasive, otherwise it will damage the skin. If you compare the list of customer requirements, at the same time engineering characteristics, you see importance weight factor. It is one of the engineering characteristics. Here you see the improvement directions, means it is given because Some values by increasing it is good, some value decreasing it is good. That way, better you read out in the terms of direction. Everything less is not okay, everything high is not okay. That's what the direction is given. So don't misunderstand the chart. So catch area. Catch area, if square meters is going up, means it is good. Then jamming probability, percentage. If the percentage is going down, is good. Accuracy of the ball return. If the dimension specification is going up, means it is very accurate and precise. Average time to return the ball. If it is in seconds, so whichever is less second is better. Means it is accurate. Sensing position of the shooter. Then lane change time, second. Lane span, energy or torque to rotate, weight, time to install the system, material rigidity, material toughness at attachment area, weather resistance. So the hierarchy of this customer requirement versus the engineering characteristics. So these are the values based on quick return ball mechanism. This is this parameter setting is a benchmark for that. So the raw score is here, relative weightage is here, and rank order is here. One of the reference. Quick return ball mechanism, house of quality, in that engineering characteristics. So the square meter catch area, if it is increasing, means jamming probability decreasing. So same way, weather resistance increasing, material toughness near who. So you have to correlate these things from catch area to weather resistance. So plus is strong and positive. So those are legends to be referred. Example of quick return ball mechanism. Room 6, customer assessment of competing products. So customer requirements is there. We studied in the first one, then later engineering characteristics we studied. Then room 4, relationship matrix. Room 6, customer assessment of the competing products. Competitor rankings. Number 1 means poor, okay, excellent. That way ratings had been given here. So CR, competitors rankings. Ball pack, pro, the boom pack, and rollback net. So these are the same with the customer requirement condition. Weatherproof 3331, accurate ball return. So all markings has been given. Example, new camera design. So your team has been charged with designing a new camera for a great camera. The first action is to construct a house of quality. So we'll see the example of house of quality related to camera. Here, house of quality example, what the customer wants. They want lightweight, easy to use, reliable, easy to hold and steady while shooting, color correction. Then what the customer wants, that is put here. Rating 5 is highest. So here reliability is much is needed here. Then how to satisfy customer wants, interrelationships, analysis of competitors, what the customer competitors has the same specification. What are the technical attributes and evaluation? Then relationship matrix. So here the low electricity requirements, then aluminum components, autofocus, paint pad, and ergonomic design. How to satisfy customer means here. These are the satisfactory points need to be fulfilled. So to the next step, what the customer want, that is relationship matrix. Lightweight 3, easy to use 4, reliable 5. Reliable is the highest one in that. Easy to hold steady, colors correction 1. So in that, how to satisfy customer wants with help of this high relationship, medium relationship, and low relationship. So high relationship at color corrections, relationship matrix, and easy to hold steady. House of quality examples. In that, we are further moving relationship between the things we can do, means how satisfy customer wants. The same thing, low electricity requirements, aluminum components, autofocus, auto exposures, paint palette, and ergonomic design. So weighted rating. In that, lightweight, easy to use. Lightweight, however, the customer requirement is 3, but in weighted rating, you see 22 our importance rating in terms of lightweight, easy to use, reliable. 9 in terms of lightweight. 27 easy to use, reliable. 27 easy to use, reliable. And 32 color correction by adding that. Easy to hold steady, 25 that relationships. So here, how well do competing products meet customer wants? Company A and company B. So if company A having a relationship diagram matrix and weightage matrix with a different value, then you can weigh between company A and company B related to the same customer requirement list. So whichever the weightage or importance rating is more, then that would be a selection criteria. Here it is a full list, completed house of quality. So partially might not have understanding, but here you can see the full length. Here the customer requirements, lightweight, easy to use, reliable, easy to hold steady, and color correction. Here the customer wants, how? These are the satisfaction or relationship diagram. Here the competitor 1, competitor 2, company A, company B. Here the target technical attributes and the technical evaluation, company A and company B. So how it works? Lightweight, low electricity requirements. Lightweight, aluminum components, means it's a high relationship compared to that. Then lightweight, ergonomic design. So color correction here, the paint palette. So these are the weightage, our importance rating. Then weightage related to low electricity requirement, 0.5 ampere. Then aluminum component 75%. Autofocus 2 to 0. Then auto exposure 2 circles. Failure 1 per 10,000, that is paint palette. Then panel ranking, that is ergonomic design. So these are the permutation combination of two different company requirements pertaining to the camera. Product design specifications. In the product design development process, the results of the design planning process that governs the engineering design task are compiled in the form of set of product design specifications. The PDSC is basic control and reference document of the design and manufacture of the product. The PDSC is document that contains all of the facts related to the outcome of the product development. Creating PDS finalizes the process of customer needs and wants, prioritizing them and beginning to cast them to a technical framework so that design concept can be established. The goal of design process planning is to identify, search, and assemble enough information to decide whether the product development venture is good investment for the company and to decide what time to market and level the resources are required. The resulting documentation is typically called a new product marketing report. This report can range in size and scope from one-page memorandum describing simple product change to business plan of several hundred pages. The marketing report includes details on such things as business objectives, product description, and available technology. Base, the competition, expected volume of sales, marketing strategy, capital requirement, development cost and time, expected profit over time, and ROI, break-even point as well. Product design specifications. In the product development process, the results of design planning process that governs the engineering design task are compiled in the form of set of product design specifications. However, it should say as little as possible about how the requirements are to be met. Whenever possible, the specification should be expressed in quantitative terms of and include all known ranges within which acceptable performance lies. For example, the power output of engine should be 5 HP plus or minus 0.25 HP, the tolerance. Remember that PDS is a dynamic document. While it is important to make it as complete as possible at the outset of the design, do not hesitate to change it as you learn more as the design evolves. Summary: engineering characteristics are discovered through benchmarking competing products, performing reverse engineering on similar product, and technical research. The TQM tool called quality function deployment is well-defined process that will lead a design team in translating the important customer needs into critical to quality engineering characteristics. The house of quality HOQ is the first step in QFD and is the most used in product development processes. The product design process results in document called product design specifications. The product is a living document and will be refined at each step of the PDP. Thank you.